Hi everyone, I'm Jackie, and today in this video, I'm going to cover must-know concepts for the SAT, in particular geometry. All of these questions have at some point in time appeared on official past SAT exams, so I would definitely know how to solve them and know these problems and the theory behind these problems. So per usual, let's jump in. So here, point P is the center of the circle in the figure shown, and AB is equal to AC. Okay, so good to know. These equal each other. And it says angle BPC, it's 60 degrees, which they tell us here in the drawing. What is the value of X? Okay, so if you ever get a problem like this, it's important to know that a little bit of a theory. And the theory is the inscribed angle theorem, which just persists. So here, if the center angle here is extending from arc BC, everyone sees that center angle. And I can also see that the inscribed angle, so BAC, it also is being cut from the same arc. So important. And notice what I'm saying, that they're cut from the same arc. So this inscribed angle theorem persists that when you have a center angle provided and the inscribed angle is cut from the same arc, it will always be half that of the center angle. So I know that this angle here, it's going to be 60 divided by 2, which is 30. This is a theorem. It is fact. Okay, but so you might be thinking, but hey, that doesn't give me X. Well, now, though, it makes their life a lot easier to get to X because I can, from here to here, this is the radius. This is also the radius from P to C. I can cut another line through here, and that would also be the radius. And remember, angles are always opposite to their corresponding sides. Since my new line here is the radius, and this is the radius, and this is also the radius, this side correlates to angle X, and this side also must correlate to angle X. How do I know that? Because it's an isosceles triangle. So we see radius, radius, they correspond to the same angles, which are X, and this would be the same. Like the radius of this side corresponds to angle X here, and the radius of this side corresponds to angle X. So I know that 2X, like X plus X here, is equal to 30. So X would be equal to 15. And that would be the answer. And it's really simple to do as long as you know the inscribed angle theorem. Okay, it is considered a difficult problem. Just to show another way in how it's been tested on the exam, could be on yours, who knows? So point P is the center of the circle in the figure shown. What is the value of X? So here I'm given opposite information. Now I should try to find what the center angle is. No problem. So just like I did before, these were the inscribed angles. I can see here too, right, that this is being cut from BC. And this angle here is also being cut from the same arc, BC. So therefore, this would also be 25 degrees, and this would also be 25 degrees. Okay, so this together, BAC, angle BAC, would be 50 degrees. And that is the inscribed angle. And the inscribed angle is half that of the central angle. So therefore, this would be angle X would be 50 times 2, which is 100. And that's the answer. Isn't that so great and amazing? Okay, so continuing our journey. Okay, so this one, you must know inscribed angle theorem very well to do this one. This is really a tough one. A great like final question for SAT exam. Okay, so let us begin. So it says in the circle above, MN has a length of 12, and KL is parallel to MN. Okay. So I know, these two lines, they're parallel to each other. What is the length of minor arc KL? Why is that good? Because with the inscribed, if they're parallel to each other, then I also know that this angle here would be 25 degrees. I have to find KL. I don't have the center angle though. Okay, but not a problem. We can do this. Okay, so here, I want to get basically the center angle here, right? However, I don't have that. But I could get what this angle is, KOM. Okay. How can I do that? Well, let's take a look. So this would be inscribed from KOM, right? Or sorry, this is, well, I'm going from KOM, but this is cut out from arc KM. Okay, I'm also going to keep it in green. Also, this angle here is cut from arc KM. So you see this inscribed angle is cut from the same arc and the same center angle that I created with KOM. So if this is the inscribed angle, the center angle will be double or twice that. So this would be 50 degrees. Okay, likewise, moving to blue, I have arc LN. Arc LN is, if I look from here, angle LMN is it cuts out from arc LN, and I could create another center angle here, which would also extend to arc LN. So since this inscribed angle, 25, is cut out from the same arc LN, this would be 50 degrees, 25 times 2. And then, now I'm almost done. I know here I'm on a straight line, right? So this must be 180 degrees. So therefore, I already have 50 plus 50, 100. So I know for sure KOL is going to be 80 degrees. Amazing, right? And we also established diameter, it's 12, so radius is equal to 6. Why is that important? Because now I have to find the length of minor arc, KL. And to get the length of minor arc, KL, arc comes out from the circumference. So I would apply the formula x over 360 degrees multiplied by 2 pi r. This will tell me what this arc measurement is. Okay, so let's do that. So I have the degrees, right? It's 80 over 360. Can cancel the zeros. This would be times 2. Radius we established was 6, so then this would be 8 over 36 times 12 pi. 12 goes into 36 3 times. So I can see this will simplify to 8/3 pi, which is correct choice B. So that was a tough one, but you see, essentially I have a really good knowledge of the inscribed angle theorem, so it's easy for me to deduce. Okay, so know inscribed angle theorem, and also know this formula here to calculate the length of an arc. It's not given to you in your formula sheet, and you should know it.
So it says a right triangular pyramid has exactly 6 edges. Each of these edges is 96 centimeters long. If the surface area of the pyramid is k root 3 square centimeters, what is the value of k? Okay, so this actually, I feel it's defined wrong because technically it's a tetrahedron, but it's fine because they give us the information in the problem that each of these edges, so it has exactly 6 edges, which just to show this would be like 1, 2, 3, 4, 5, 6. Okay, for the 6 edges. Each of these edges is 96 centimeters long, so 96, 96. 96. 96, guaranteeing that it's actually an equilateral triangle. And then it says the surface area of the pyramid is. So imagine what the surface area of the pyramid would be. Um, Remember shortcut for equilateral triangle. If I want to calculate the area of just one equilateral triangle, s squared root 3 divided by 4 will give me that. That's for one, but then I would multiply this by 4 to calculate the surface area because there's 4, right? One, oops. We'll just show 1, 2, 3. I hope you see like it. There's this one here, 1, 2, the back one, 3, and then the bottom one, 4. So I just need to get the area of each face, multiply it by 4, and that should be my answer. And then that's exactly what I'm going to do. So surface area, SA, equals 96 squared root 3 divided by 4 times 4, just to show the 4s would actually cancel. And I'd be left with 96 times 96, 92, 9,216 root 3. And remember, it tells me that this is equal to k root 3. So therefore, 9216 is equal to k, and that's my answer. Wasn't that amazing? Um, Continuing our journey. Okay, so this one, the study of fluctuations in leaf water potential, samples of wood were taken from 22 trees and cut in the shape of a cube. The length of the edge of one of these cubes is 3 centimeters. The cube has a density of 0.250 grams per cubic centimeter. What is the mass of this cube in grams? So a couple things. That first, a cube, it's not given to you on the formula sheet of the exam. So the volume of a cube, it's always edge cubed. You should know that for the exam. Remember, not given to you on the formula sheet. And also not given to you is density. So you do want to be comfortable with cubes and density on the exam. And density, it's always a mass over volume. Okay, so my first mission would be to find the volume of the cube, which would just be 3 cubed, which is equal to 20, oops, ah, 27. And then it says the density. So density, it's 0.25 is equal to mass, what we're solving for, over volume, which we know is 27. So basically 27 times 0.250 will equal the mass. Let's see what that is. Which is equal to 6.75. And that would be my answer. Awareness wasn't that amazing, but main takeaways for this problem, remember, cube comes up a lot in the exam, not in the formula sheet. You should be familiar with the volume. And density occasionally comes up and not provided on the formula sheet. So make sure you know the formula for density and for the volume of the cube. Amazing. Continuing our journey. Okay, a triangular prism has a height of 9 centimeters and a volume 234 centimeters cubed. What is the area in the centimeters squared of the base of the prism? The volume of the triangular prism is equal to base times height, where b is the area of the base and height is the height of the prism. Wow, that was so nice of them to give this in parentheses. And remember, they do occasionally do this, depends on the exam and the problem. So this one, I think, straightforward, but it tells us, right, that volume is equal to base times height. So I know that the volume, it's 234 centimeters cubed, and it's equal to the base times the height, which I can get what that is from, because it's provided. So base times 9, and I am just asked for the base. So 234 divided by 9, and 26 is equal to the base. That was super simple. But I mean, these problems appear on SAT and you want to be comfortable solving them. Okay, so next up we have the edge length in inches of cube y is 3/64 the edge length in inches of cube x. The surface area in square inches of cube y is n times the surface area in square inches of cube x. What is the value of n? Okay, so imagine we have a cube. And remember, cubes are not given to us in the formula sheet of the exam. Okay, so cube x, each of its, we're just gonna make it one, do. And then we have cube y, each of its edges are 3/64. Just a rough sketch. Okay, and then the surface area of cube y is n times the surface area. Okay, so if I want to find the surface area, important that you know this formula, surface area, it's 6 times area or side squared. So I would find like the area of a square, multiply it by 6 because there's 6 faces of a cube. So 6 times 1 squared, this is just 6. And if I do the surface area of cube y, it would be, make sure you square the top and bottom. So this would become 9 over 4,096. Which I can multiply this by 6 and make this 54 over 496. And dividing everything by 2, this would just simplify to 27 over 2048. Okay, so I can see that would be the surface area of cube y. And then I'm asked, it's n times the surface area of cube x. So now I can just set a ratio of the surface areas. So I can say the surface area of, we'll say cube y, to the surface area of cube x, which will be 27 over 248 divided by 6. So that would be the same as multiplying by 1/6. And then this would simplify to 27 over 2048 over 12,288. And then dividing everything by 3, it simplifies to 9 over 4,096, which looks exactly like correct answer choice A. And that makes sense because I can see that like cube y's surface area, it is that many times smaller, 9 over 4,096 times smaller than cube x's, which makes sense because its edge length was much smaller. Okay, amazing. Continuing our journey. Oh my goodness, what about this one? The length of the edge of the base of a right square prism is 6 units. The volume of the prism is 2,880 cubic units. What is the height of this prism? So a right square prism, it's just going to be, well, the face will be square. It's basically a rectangular prism. So imagine a rectangular prism. However, the bases are squares. Well, that's a rough sketch. Okay, I drew it better. So basically, I can see that the bases here, it's a square, and we have also a square here. Okay, amazing. So if normally in a rectangular solid, if I wanted to calculate the volume, it would be volume equals length times width times height. But here I can see the length and the height and the width are basically the same. So I have length, width, and height. So instead, this will basically just be, instead of length times width, just side squared multiplied by height. So if I know the edge of the base of a right square prism at 6, this is 6, and this is 6. So therefore, this would be 6 squared. The height I'm solving for, but I also know 22,880 is equal to 36h. And then I just need to divide each side by 36. Let's see what that is. Oh my goodness, and it is 80. Okay, so this is given to you on the exam, but good to know that a right square prism just means it's a similar to a rectangular prism, except the face will have two squares. Wasn't it amazing? Okay, so next we have a rectangular region of land is divided into 88 square lots of equal area R in square units. The length of the region is 5.5 times the width of the region. If the width of the region is x root r units, what is the value of x? Okay, so if the area is divided into 88 square lots of equal area r, there's one, if I multiply 88 by the area r, this would be give me the area of the rectangular region of land. And it also says that this length of the rectangular region can be defined by the way I'm doing length times width, is 5.5 times the width. So the length would be 5.5 multiplied by x root r, because that's what the width is, multiplied by the width, which is x root r. So you see this would be my length and my width, it's x root r. So simplified, this would be 5.5 x squared times r. And then I have two formulas, therefore I can set them equal to each other. So this would just be 88r is equal to 5.5 x squared r. Divide out r. And I get 88 is equal to 5.5 x squared. Divide each side by 88 by 5.5. This will give me 16. And take the square root. And I get that x is equal to 4. And that is our answer. Wasn't that so amazing?
Okay, so this one says the perimeter of an isosceles right triangle is 26 plus 26 root 2 inches. What is the length in inches of the hypotenuse of this triangle? Okay, so first things first, we need to know the 45, 45, 90 triangle. This is given to you on the reference sheet of the exam, but you should know it anyway. So it's x root 2. Okay, I'm told the perimeter, so I can sum these side proportions and get 2x plus x root 2 is equal to 26 plus 26 root 2. Okay, so from here though, I can't set like 2x is equal to 26 because that would give me x is 13, which we can see isn't possible because this has to be 26, 26. Okay, so then the key actually here is to factor. So what I can factor out is actually the x root 2, and then this would be the same as root 2 plus 1, right? So I can see if I did multiply this gives me 2x, and multiply this gives me x root 2. Okay, so then going to the other side, I want to have the same factorization happen. So from here, I could say that this would be the same as if I factor out the 26, so 26 root 2 plus 1. And you can see here it gives me the 26 root 2, and here would give me the 26. So then I can divide each side by root 2 plus 1. They nicely cancel, and I'm left with that x root 2 is actually equal to 26. And then I want to go ahead and rationalize out the square root. So I'm going to get 26 root 2 times root 2, which will root 2, which will simplify to, well, I'll show all the steps. 26 root 2 over 2, which is 13 root 2. And this is what x is equal to. Okay, so, and that seems to make sense because then this would be 13 root 2, this would be 13 root 2, and this would be 13 root 2 times root 2, or 13 times 2, which gives me, just to show all the steps, 26. And I'm asked for what the hypotenuse of the triangle is. Well, it is 26. Okay, and that also makes sense because if I go here and do 26, or sum these together, 13 root 2 plus 13 root 2 plus 26, that gives me exactly what I have above. Isn't it amazing? Okay, so no, this concept could be useful and helpful in solving. Continuing our advanced geometry journey. Okay, so let's look at this question. So here, we're given a triangle, and it says in the figure above, triangle ABC and BCD are right triangles. AD equals 8, BD equals 6. What is the length of DC? Okay, so here, if I wanted to solve this, my first thing that I recognize, this is a Pythagorean triplet. It's a 6, 8, 10. And I need to get the length of DC. Okay, so I'm gonna just label this A and this B, just to show. So if I were to, so for these problems, you want to think about flipping the triangle. Let's see what happens if I invert triangle ABC. So in this case, the B is here, C is here, A is here, and the BD is here. Okay, so then I have the hypotenuse here, which is 8 plus A, and then I have the AB value. AB is 10, oops, 10, and our CB value is B. So just to show what that looks like, and then I can use Pythagorean theorem. So B squared plus 10 squared is equal to 8 plus 8 squared. And also we can look here that from this triangle, I can create another Pythagorean theorem so that I have two equations. So this would be like a squared plus 6 squared, oops, a squared plus 6 squared is equal to b squared. Okay, and so let's go ahead and expand the brackets here. So this is 100, and this would be a plus a. Remember to expand the brackets. So this becomes b squared plus 100 is equal to 64 plus 16a plus a squared. And then, let me just make that a little bit nicer. Okay, a squared. And then I have a system of equations, so I can do substitution. I know from here that my b squared is equal to a squared plus 6 squared. So I can also go ahead and substitute that in here. And then that would give me a squared plus 36 plus 100 equals 64 plus 16a plus a squared. So subtract the a squareds from each side, they cancel. Subtract the integers, so it'd be like 136 minus 64, 72 equals 16a, and then divide by 16, and I get that 4.5 is equal to a. And the a value was what I labeled DC, so that would be the answer to type in here. Okay, so if you get a triangle here on the exam, it seems really complicated, always consider flipping it because perhaps that is the trick to solving the answer. Okay, so another concept that could come up and would be good to know are polygons. So here we have the problem, a polygon has 95 sides. If each interior angle is given by 180 p degrees, what will be the value of p? Okay, so first, if I want to find the actual amount of degrees that a 95-sided polygon has, I can use this amazing formula, which is n minus 2 times 180. This will tell me like the sum of interior angles of any n-sided polygon. So let's do that. So this would just be 95 minus 2 times 180, which is 93 times 180. And that gives me 6,740 degrees, which makes sense. It has 95 sides, so it makes sense that there would be a large amount of degrees for the interior angle measurement. Okay, so I know the actual amount of degrees that this has, and it also important, it does say that each interior angle is given by 180p degrees. So expressing that algebraically, I would know that each of these angles, so 180p times all 95 sides, let's see what that equals, is equal to 17,100p. Okay, so what this is telling me is that each interior angle, it has 180p degrees, and that means that each angle, each of those 95 angles, has exactly 180p degrees. So that's why, since there are 95 angles and each angle is the same, that's why I'm multiplying them together. And then now I have two expressions that I know are equal to each other. They're both the sum of the interior angles of the polygon, and I can set these equal to each other. So let's do that. And then divide each side by 16,740 divided by 17,100. And that gives me like approximately 0.9795. And looking at the answer choices, the fraction that gives me that exact value, it is 93.95. And that would be the answer. Okay, but so main takeaways for this problem, make sure that you know this formula could be helpful, and look for language to help you, in this case, like each interior angle, because that could be the key, to solving this problem. Okay, amazing.
In the figure shown, AD is equal to 16, AB is equal to 20. What is the length of BC? Okay, so first things first, I can get what BD is immediately. It's a multiple of 3, so this would just be equal to 12. And the reason I know that quickly without using Pythagorean theorem is this would be like a 4x, 3x, 5x. It's the Pythagorean triplet, the 3, 4, 5. And just to show, like it's 4 times 4, multiples of 4, 3 times 4, 12, and 5 times 4, 20. So since I saw, this was 20, this was 16, I knew almost immediately multiples of 4, 12. Pretty wild, right? Okay, so next, let's see. So what I would do is just like I can label this A and B for simplicity. And you can always, let's rotate this triangle on its side. So when I rotate the triangle on its side, we would have B here, like the D now would be here. This would be C, this would be A, and hypotenuse would be 16 plus A. My CB value is what I labeled as B, and my AB value, we know it's 20. So you see, I've flipped that onto its side. And now let's look at my triangle here, my pink triangle. Okay, so I can create an equation. I can say 12 squared plus a squared is equal to b squared. And I can also create an equation with this triangle here. I know that b squared plus 20 squared is equal to 16 plus a squared. Amazing. And then now what I can do, oh my goodness, look, I have what b is, so I can substitute this in for here. Let me do that. Do dee dee. So this would be um, basically 144 plus a squared plus 20 squared, it's 400, is equal to 16. Make sure you expand the brackets. 16 plus a, 16 plus a. So this would be 544 plus a squared is equal to 256 plus 32a plus a squared. Subtract the a's from each side and then subtract 544 minus 256. It is 288 is equal to 32a. Divide by 32, and I get that 9 is equal to a. So that means 9 would be a, but careful, that could be a trap answer. I'm not asked for DC, I'm asked for BC. And just to show, this would be 15. Answer. And the reason I know that again so quickly, yes, you can do Pythagorean theorem, but just to show, it is another Pythagorean triplet. 9, 12, 15, they're multiples of 3. The 3, 4, 5 triplet. So this is 4 times 3, and this is 5 times 3. 3, 3, multiples of 3 of the 3, 4, 5. Wasn't that so amazing? More geometry. So in the figure shown, O is the center of the circle, and A, B, and C are the points on the circle. If the measure AOB, so that would be the center angle, 72 degrees, what is the measure of ACB? Okay, so if you don't know this theory, pay attention and know it for the exam. So I can see that my center angle, it cuts out from arc AB. And if I look at the angle they're asking for, ACB, it also extends from AB. So the inscribed angle theorem posits that any inscribed angle that is extends from the same arc as the center angle will always be 1/2 of the center angle. And that's all I have to know. So I know that ACB is just going to be 72 divided by 2, which is 36. And that's the answer. Simple. However, you have to know this theory, right, in order to solve it. How amazing. So let's look at this one. Okay, so here it says in the figure, AC is the diameter of the circle with center O, and AC is 10. So whole length 10. Triangle ACB is equilateral. Helpful. So all of the degrees would be 60 degrees. And the length of BP is n times the length of AO. Okay, so this I can solve using my knowledge of 30, 60, 90 triangles. So if this is 60 and this is 30, this would be x, this would be x root 3, and this would be 2x. So therefore, I know that this is 5 and this is 5. Also the height here, so I'll put it also here. So we can see that the height would be 5 root 3, and this would be like BOA for my triangle. This would be 5, and this is equal to 10. Okay, so I know that. And then from here, I can see from O to P, that would just also be the radius, right? Coming out from the center of the circle. So here it is 5. And if I want to find BP, BP will just be equivalent to BO minus PO. And I have what BO is, right? We know BO, it's 5 root 3. minus PO, the radius, which is 5. And another way to see that, they each have 5 in common. I can factor this out. So this would be root 3 minus 1. And it asks me BP, this is BP, is how many is n times the length of AO. I know AO is 5, so 5, this is square root 3 minus 1 times the length of AO. And therefore, our choice would be correct choice C. Oh my goodness, how amazing. All right, next up we have this interesting one. Okay, so it says in the figure BC is the diameter of the circle. If the length of BC is equal to 132, okay, so I know this is 132, and the length AB is equal to square root 363. What is the value of BC to BD? Okay, well, I think important to know, and you should know this for the exam, is an important thing about diameters and right angles in circles. So in any circle, if a point lies on the circumference and is connected to the endpoints of the diameter, it's going to form a right angle with the diameter. So this is also known as inscribed angle theorem of the diameter. But anyways, why am I saying this? Because here I have that BC is the diameter, right, of the circle, and angle BAC. So this one here, I'll put in highlight and then erase, but BAC. So this angle here, um, it's subtended by the diameter. So I know for sure that this angle is going to be 90 degrees. So it's a little bit of theoretical background knowledge on that, but that's why I know for sure that angle BAC is 90 degrees. Alrighty, so then I know that triangle ABC is a right triangle, right? And looking, so we can see, right, that this triangle, it's a right triangle. And then I also have another triangle, right? ADB, so this triangle here. It's 90 degrees. So I have two right triangles happening within this triangle. So I know that ABC, triangle ABC, it's going to be similar to triangle ABD. Similar to triangle ABD. Okay. And why is this? Because I can see first they're both right angle triangles, and also they are sharing a common angle, angle A up here, and it's it's sharing in both triangles. And then I know it applies or checks off the boxes for our angle similarity theorem. So basically, when we have two corresponding angles that are equal to each other, I know that they're going to be similar. Okay, so I know for sure ABC is similar to triangle ABD, and that's very important to solving the problem, which is why I've mentioned it. Okay, actually, this should just have one line, not two. That would be approximate. Okay, so anyways, now I know proportions, I can set them up. So I know that AB, oh, oh my, what happened? Okay, well, sorry, I wanted to like erase that all. So I know that AB is similar to BC, and that's similar to BD, which is similar to AB. So everyone sees that like AB, BC, and then we see BD and also AB. Okay, so now I know that based on similar triangles that the sides are proportional to each other. And then all I need to do is put in the values. And it really is just that simple. Like, let's put it what I had before. So AB, it's square root of, oops, sorry, 363. And BC, I know it's 132. BD, I don't know. That's what I'm solving for. And AB, also, it's 300 and square root of 363. And then all I need to do is cross multiply. So I would get like 132 BD is equal to 363. Then just divide each side by 132. Do dee dee dee. Which is just 363 over 132. So I have what BD is, and I'm asked what BC to BD is. So BC, I know it's 132, and BD we just identified as 163 over 132. And let's simplify. So this would really be like 132 multiplied by 132 over 363, which is simplifies to the correct answer, which is 48. And since I feel that I'll probably get questions in the um about the similarity, let me just clarify again that so we see right in the larger triangle. So just to be clear, in triangle ABC, it's similar. My hypotenuse, it's BC. Okay, and that's similar to the hypotenuse in triangle ABD, this one here, which is similar here to AB, which is what I put up in my setup over here. And then likewise, let's look at the legs opposite to the right angles. So in triangle ABC, our larger one, my my leg, it's AB, which I'm putting here, right? And um and then my in triangle ABD, I'm referring to this leg. Okay. So that's what I put here. Okay. I just wanted to re-clarify that for similarity. And that's why we can set, the proportion that I did. Hopefully that's clear. And remember the point that I also made at the beginning um, about knowing how to get the right angles. Okay, amazing. Okay, so let's continue our journey. So I've been doing this for the last couple of prediction videos, but it's fundamental and necessary to know three-dimensional figures. So let's take a look at this one. Classic right square pyramids. So a right square pyramid has a height of 11 centimeters. A second right square pyramid has a height of 22 centimeters. The area of the bases of each of the two pyramids is 100 centimeters squared. Which of the following is closest to the difference in surface area of the second pyramid and the surface area of the first pyramid? Okay, so I just drew them out here. But if I want to calculate the surface area, imagine if we unfold this amazing right square pyramid. I would have triangle, 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 and another triangle. They would be equal, but we can see, right, that the area would be the area of the base, aka the square, multiplied by the area of the four triangles. So why don't I find the area then of the triangle? So if I know here that the area of the bases, it's 100 centimeters square, then I know that all these are 10 and that this would just be half of 10, which is 5. And same here, this would also be 5. Then with this, I can calculate the slant height of our pyramid by doing, quickly Pythagorean theorem, 5 squared plus 11 squared equals c squared, which would be, and then same here, we would do 5 squared plus 22 squared, which will be equal to the slant height. So in this case, we have 25 plus 121 equals c squared, which is 146 equals c squared. That is not a perfect square, so I'm just going to leave that as is, that its square root 146 is equal to c. Okay, same here. We would have 20, uh, so this would be 25 plus 484 equals c squared, which is 509 equals c squared. And then I would take the square root, but this is also not a perfect square, so I'm just going to keep that as is. Okay, so that's why probably it says closest to, it's approximation. So I know that the slant height here, it's square root 146, and the slant height here is square root 509. So imagine, so here, if I wanted to calculate the area of the triangle, I have the base, that's 10. Slant height here, it's square root 146. So I would just do, right, base times height divided by 2, which it's 5, 146. But then I need to multiply it by 4 because it's for all the 4 triangles. So this would be 20 root 146, and then plus the surface area, which is 100. Okay, so we have our area for there. And then same with this one, I'm going to do the base of 10 multiplied by its slant height, 509, divided by 2, which we see it's 5, and then also multiply by 4, which is 20 root 509 plus 100. Okay, so I can see that really the difference between the total surface area of the smaller pyramid and this one is essentially the square root in between them. So now I'll just calculate the difference of that. And just to show, whipping out Desmos here. Oh my goodness, look at this. So like 20 square root 509, 20 square root 104, it's approximately 209.55. And looking at the answer choices, that would be closest to option A. So know your right square pyramids. They've been heavily frequented on exams, and then your life will be amazing. Okay, let's continue our journey. Alrighty, now let's look at this one. So the table gives the areas and perimeters of two similar rectangles where n is a constant. Okay, so I see rectangle A, I have its area, I have its perimeter. And rectangle B, I have its area and I don't have its perimeter. And then I have to find what the value of n is. So important to recognize in this problem, it says that it's two similar rectangles, which means that the ratio of their areas is going to be the square of the ratio of their side lengths. And that's an important thing to remember. And also, the ratio of their perimeters will be the same as the ratio of their side lengths. So I can just set up like the area of B to area of A, which would be 9,800 over 2450. And oh my goodness, I think this goes in perfectly. Oh my goodness, it's 4. Okay, so that means that the area of rectangle B, like area rectangle B, is 4 times area of rectangle A, which I think makes sense, right? Okay, but so if I want to like relate this ratio of the side length, what I'm going to do, since again, I can do this because the rectangles are similar, then I know that the ratio is the square of the side length. So basically, I would just be like, all right, so k squared, k for square, for, for the side is equal to 4, and then take the square root. So I would have that the side length of 2, which just means the lengths of rectangle B are twice those of rectangle A. And then, now I know that. And now I can calculate. Basically, all I have to do is do 2 times 490, which is 980. And that would be my amazing answer. Okay, so hopefully that makes sense and is amazing. But just basically remember that side lengths in similar rectangles, they will correspond to the different side lengths that they're scaling up by. Perimeters, they always scale by the same ratio as the sides, and areas, they scale by the square of the side ratio. Okay? Remember what I said. Okay.
So first things first. Here in triangle PQR, the measure of angle P is 3x plus 5 degrees. The measure of angle Q is 2x plus 9 degrees. And the measure of angle R is 4y plus 5 degrees. If side QR is extended through point R to point S, and the measure of angle PRS is x plus y degrees, what is the value of x plus y? Okay, so always for geometry questions, draw them out to help give yourself a visual. You do get scrap paper on the SAT. So this would be 3x plus 5, Q, it's 2x plus 9, and we know that R is 4y plus 5. Okay, and then it says that side QR is extended through to point S, so this goes down here, and we'll say that this is our point S. And then this angle, PRS, so the PRS pertains to this angle, and this angle is x plus y. Okay, so definitely it appears that I'll need to create a system of equations. So first, I know a triangle has 180 degrees. So I'm going to first sum P, Q, and R. So do 3x plus 5 plus 2x plus 9 plus 4y plus 5. And then combine all the like terms. So combining the x's, that'd be 5x, 5 plus 5 plus 9, so plus 19. Plus 4y equals 180 degrees. Now subtract the 19 from 180. So I'm left with 5x plus 4y is equal to 161. Next, I know that this is x plus y, so look here. Yes, I'll put in red. So from here, I have a straight line, right? So I know that the sum of these two angles, 4y plus 5, as well as x plus y, angle PRS, is going to also sum to 180 degrees because it's on a straight line. Straight lines are 180 degrees. And again, I'm going to combine like terms. So for this one, I would have 5y plus x. I'm going to just move the 5 to the other side. So it's equal to 175. Okay, and then from here, I have two system of equations, and then I can simply solve for x or y. So let's go ahead and do that. Okay, I'm going to do this one. I'm going to say that x is equal to 175 minus 5y. And then I can go ahead and substitute this in for x up here. Okay, so let's do that. So this would be 5 times 175 minus 5y plus 4y is equal to 161. Now distribute the 5. So 5 times 175, that's 875. And 5 times 5 is minus 25y plus 4y equals 161. Combine the y, so I'm left with 875. Minus 21y is equal to 161. Subtract the 875 from each side. So I would have negative 21y is equal to negative 714. Now divide each side by negative 21, and I get that y is equal to positive 34. Okay, and now I know what y is equal to, so I can just go back to any one of the equations. Let's go back to 5y plus x. That is equal to 175. I'm going to now substitute in the y, that is 34. And then we can get our x value. So 5 times 34, that is is 170. So I have 170 plus x equals 175. Subtract 170 from each side. X is equal to 5. And remember, we are asked for the value of x plus y. So x plus y is going to be x is 5 plus 34, and that is equal to 39. And that is what I would type into the answer sheet. Okay, so that one was amazing. Doing, oh, triangle inequality theorem. So in this problem, it's actually nice because they tell you what the triangle inequality theorem is. However, I always tell my students you should know it anyways, just in case they aren't as nice and don't provide what it is. So the triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the length of the third side. Okay, so think of a triangle, imagine three sides. The sum of two sides must be greater than the third side. That's English translated into math. So if a triangle has a side lengths 8 and 13, so let's label this 8 and this 13, which inequality represents the possible lengths x of the third side of the triangle. Okay, so I can always calculate the range of the triangle inequality theorem by simply summing the two sides provided. So we'll do 13 plus 8, which is 21. So that would be my extreme end. And then I would also do 13 minus 8, which is 5. And so when I know this, then I know that angle Z, for example, would have to fall in between. It must be greater than 5, but also less than 21 for it to be a triangle. And oh my goodness, can you look at this? Well, they asked for X, I called it Z. Same thing, it matches option C. And just to prove why that would be true. So for example, if I did put 5 in for Z, that doesn't work, right? Because 8 plus 5 greater than 13. No, that's not true. But 5.1 would be, or if I did 6, it would be. I hope that makes sense. But know the triangle inequality theorem for the exam in case that they don't give this introductory sentence. I'm actually surprised that they did do that. Okay, and then continuing, we have a couple others. Amazing. So the table gives the perimeters of similar triangles TUV and XYZ, where TU corresponds to XY, and the length of TU is 6. Okay, amazing. And I'm asked for what is the length of XY. So let's see. Okay, well, let's just draw this out for visual purposes. So if I have triangle TUV, and then I also have triangle XYZ. Okay, and then it tells me that TU is 6. So if they're similar, I know that TU is going to correlate to XY. I also know TV is going to correlate to XZ. And I also know that UV is going to correlate to side YZ. Okay, amazing. So I'm asked for the length of XY. Okay, so similar triangles, the ratio of the perimeters of the triangles is equal to the ratio of the corresponding sides. Important, take note of that. So therefore I can just set, for example, like triangle XYZ. and triangle TUV. And then I could say that will be equal to length XY. And then this would be equal to the length of TU, which was given. And now I just need to substitute all the values that they've given us. So I know X, Y, Z, it's 150. So 150. XY is what I'm solving for. TUV, it's 50. And I also was given that TU is 6. And now I just cross multiply. So we'll do 150 times 6. 900 is equal to 50xy. And then divide each side by 50, which is 18. And oh my goodness, that looks like an answer choice C. Okay, so remember, similar triangles, the ratio of the perimeters of the triangles is equal to the ratio of the corresponding sides. And that's how you can solve that one. Okay, so this one, we have in the figure AC is equal to CD. Important piece of information. So just label that. So AC is equal to CD, which means that this triangle is isosceles. So remember that in triangles, the sides are always opposite to their corresponding angles. So this corresponds to this angle, which will be the same, and this corresponds to this angle, which will be the same. So my pink angles are going to be the same. Okay, so then we also are provided that EBC is equal to 29. And we also know that ACD is equal to 108 degrees. Okay, what is the value of X? So, well, first, I would first just do 180 minus 108, which is 72. And then I would divide by 2 because I know that these angles are the same because it is an isosceles triangle. So each of these are 36 degrees. Okay, but still not enough to give me what X is. No problem. So also I can go here and I can do, again, 180 minus 108. This one, it's going to be 72 degrees because it's on a straight line. And then I can do 72 plus 29, which is 101. And then minus 180 minus 101, which is 79. And then here, these are vertical angles here. So this would be 79 and 79. Vertical angles are always congruent or equal to each other. And then finally, I would do 79 plus 36. And then, which is 115, and then do 180 minus 115. And let's see what that is. Oh my goodness, it's 65 degrees. And that would be the value of X. But, you know, in the sheet, or not the sheet, in the computer, I would type 65. Oh my goodness, wasn't that amazing? Okay, oh my goodness. So you might be thinking to yourself, this is a lot of geometry questions for one SAT exam. These are from various SAT exams from June, but from different countries. So you get a little feel of all the areas of the world. Okay, so let's see. I'm giving this shape. Looks like, well, let's see what it says in the figure. NP is the diameter of semicircle O. Angles Q, R, and S are right angles. Okay, Q, R, S, right angles. And point P is the midpoint of NQ. Okay, so PQ is equal to 52. Okay. And NS is equal to 18 feet. Okay. The area of the figure can be expressed as a pi plus b square feet, where a and b are integers. What is the value of a minus b? Okay, so first, let's see. I would know just that this is also 18. And then the next thing I would do, all right, so I know that point P is the midpoint of NQ. which means that this whole length would also be 52, which would mean that the radius of the semicircle is 26. So let me put this is 26 and this is 26. Okay. And then next I can calculate then the area of the semicircle. Let's do that. So the area would just be pi r squared, but divided by 2 because it's half of a circle. And then I can do that. Area is equal to pi. The radius is 26, 26 squared, and then we will divide by 2. So let's calculate. 26 times 26, 676 divided by 2. So the area of the semicircle is 338 pi. Okay, so next up on our agenda. Okay, then next we can calculate the area of the rectangle. So remember, this is 52 plus 52. So this is 104. So rectangle would just be 104 times 18. And that is equal to 1872. And it says that the area of the figure can be expressed as a pi plus b, and this would be 338 pi plus 1872. And then I'm asked, what is the value of a minus b? Okay, so my a value correlates to 338, and my b value corresponds to 872. And final step would be 338 minus 1872, which is equal to negative 1,534. And that would be, the answer that I type in. You can type in negative numbers. Okay.
Okay, those were a lot of geometry problems, but I think if you know all of these and you feel comfortable with them, you'll do amazing in the geometry questions on the SAT. And if you liked the video, like, rate, subscribe, tell your friends about me, share the video, give more love so we can help everyone get their perfect SAT scores. Okay, thank you for watching, and I'll see you in the next video.